Hello, I gonna be doing a video here. It's gonna be on technology and history of technology and communication. I just wanted to play a brief clip here. It's on how to send an email, and it was recorded on July or June 7th, or July 6th, if that's how they measure it in England or Europe at least.
Hello, Jane.
Now, Julian, I see you have your computer linked to the telephone line. Can you tell us how you did that?
Yes, well, it's very simple, really. The telephone is connected to the telephone network with a British Telecom plug, and I simply remove the telephone jack from the telecom socket and plug it into this box here, the modem. I then take another wire from the modem and plug it in where the telephone was. I can then switch on the modem and we're ready to go. The computer is asking me if I want to log on, and it's now telling me to phone up the main Prestel computer, which I will now do.
It's a very simple connection to make.
Extremely simple. And I can actually leave the modem plugged in once it's done that without affecting the telephone. I'm now waiting for the computer to answer me. It asks with a tone, and then I just flick a switch on the modem and replace the receiver. And
Things are starting to happen.
things are starting to happen. The Prestel computer is now asking me to enter my own personal password, which I've now done, and it comes up with an opening screen.
Now, Julian, can you tell me, what is Micronet?
Well, Micronet basically is an area of Prestel that's specially designed for microcomputer users. It has a lot of facilities. It has a magazine-type page of what's new today, the daily news, reviews of the current software that's available. There's a letters page so people can write in. There are programs available on Micronet that you can load directly down the phone line. Some of them are free, some of them you do have to pay for.
Now, Pat, whose computer is it?
Well, it's a cooperative, really. We all have a part share, but Julian and I mainly use it.
And why did you buy a computer?
Well, I was very interested in the new technology and didn't want to be left behind. I don't think it's only for the youngsters at school now. I think us older ones will have to learn a lot about it.
And what do you use the computer for?
Well, for keeping household records, such as what I have in the freezer and people's telephone numbers and addresses. I use it as a word processor for my letters, which always come out perfect now. And the most exciting thing I find is the mailbox where I write to other people on the Prestel system.
And who have you written to recently? You got any examples?
Yes, I sent a message to my doctor.
So, I just saw this video for the first time today. I don't even think I've heard of Micronet, but I am aware that there were some, early email systems that are very different from the ones that are in use today. So I was a little surprised that they had email back in '84. I know they had it in the late '80s, but this is must be a really, really old system. Very interesting, nonetheless. Actually, this guy kind of reminded me a little bit of the guy from the IT crowd. Anyways, just returning to writing technologies. I kind of wanted to compare cell phone internet to the early desktop era of internet, like you just saw. But I also wanted to tie it into some of the older technologies of long distance communication, to telegraph, phone lines. But I also was looking really ancient writing as a form of technology. I remember reading like a few months ago or something, mentioning writing is also a technology. So going all the way back to ancient times, when so it just says technology is an ever-evolving and ever-changing, is ever-evolving and ever-changing, and writing, when you think about it, is a form of technology. And so this article goes to determine when writing began. So it says that it was independently invented in at least 4 times in human history. The first time in Mesopotamia, of present-day Iraq, where cuneiform was used between 3400 and 3300 BC, shortly afterwards in Egypt. At around 3200 BC, by 1300 BC, we have evidence of a fully operational writing system. In late Shang Dynasty China, sometime in between 900 and 600 BC, writing also appears in the culture of Mesoamerica. And then I recall reading this article, not this one. There was another one. Just thinking that when writing was introduced, it was somehow in competition with like teachers, and there was the fear that it would compete with teachers and things, but actually it was nope, not that. I just had the article. I can find it. Vice. Yeah, this one. Pages. So this article I mentioned before in a few of my writings, but I recall reading this and remember reading that apparently in discussions with philosophers back then, they emphasized the importance of spoken word as opposed to written word. So as technology progressed, there was more emphasis on writing as a form of information, not necessarily knowledge, as you can't just, become knowledgeable just by reading, of course, but it's kind of like a practice, and of course it's somewhat relative in a sense, because information gets encoded, and as generations pass, like the interpretation of information also changes, so it doesn't always have the same meaning, and language also changed. So philology is the study of the origination of words and language. So philology, the branch of knowledge that deals with the structure, historical development, and relationships of language. So if writing is a technology, then in a way philology is like studying the history of one type of technology. Obviously this isn't the first time this concept has been brought up, but if you were to compare it to something like open source technology and the interest in preserving old technologies or old software, then this is one way that can be somewhat interpreted. And Another thing about transferring knowledge through history, or call it not college, but through teaching, is oral traditions. So oral tradition is another way that information practice a form of communication where knowledge, art, ideas, and cultural material is perceived, preserved, and transmitted orally one generation to another. So, writing as a form of transferring, information, knowledge from one generation to another is just one evolution of of human culture. So since the time of writing, writing has become somewhat in competition with oral traditions, and that's been that way for more than 3,000 years if you go by that one estimate. So 3,500, but continuously you could say it's been in writing has been around for at least 2,000. Yeah, I would say almost 5,000 years or so. And so looking into other developments throughout the past, 2,000 years, there have been, stone tablets for centuries, and then around the 1400, the Gutenberg printing press allowed writing not only to be hand-scribed, but to be automated. Not automated, but to use like little tiles to print. I'm sure there's a word for it, but it is more mechanical than just paper or something that is letterpress printing. So let me see if there's a picture here. Movable type. So obviously there's a little bit more involved here than just writing it. So this had the advantage of mass producing books or papers, newspapers, in a way that was faster than someone hand writing it. It could also introduce more accuracy in a way. Even a scribe that's making a copy, could make an error. Which isn't to say that this is necessarily better. I mean, there could be things that can get missed, especially in the in cursive. There could be things that could hint like accents of writing. And that went on for like maybe 400 years, and then the telegraph was developed in the early 1800s. The telegraph, late 18. Telegraph dates only from 1832. Morse. Well, actually, there was optical telegraph that was communication that would allow shortest possible time. 1791. Well, these were sort of like short-lived, but they were definitely a mode. But I kind of look at the Morse code as like the first established system, which was begun electromagnetism, 1820. 1848. Okay, so 1848, the modern international Morse code. So all I just wanted to say about that is that it allowed information to be transmitted without having to use a courier to deliver a book or a newspaper. So Morse code using the telegraph was able to like send something. It was like the first internet in a way, like sending a text message, a very short code, since each letter had a certain series of dots, or a specific pattern of dots here. And moving on to the 1900s, the 20th century, there was like another major significant development in radios. So the early 1900s were not only radios, but shortwave and radio telegraphy. So it combined radio with Morse code. And so there were some interesting developments back then that I'll just close these for now. Transatlantic, and then of course these were also being used to go across overseas, even though that was the main reason it was a benefit, because it can go overseas without having to use a ship to mail a letter. So that was a big advancement, and then we'll just close all these other. That'll be later. I already covered this, and I'll cover that in a second. So, okay, so shortwave, I just wanted to cover that briefly. And then, so the first over-the-air transmittance that didn't rely on underground telegraph cables was that Nova Scotia or Cornwall? Wait, it was... So the first transmittance over the ocean, the Atlantic Ocean, was from England to Canada, and it was... I'm just, some of the font is a little large here, so I kind of have to zoom out here. It was Newfoundland St. John's, I think. I remembered all this like a few months ago. I didn't have this link prepared here. So the original shortwave, just look up shortwave. Okay, that didn't. Let's go back here. Okay, well, there was also one from Ireland to England. And then Nova Scotia. Okay, so December 17th, 1902, a transmission from the Marconi station in Glace Bay, Nova Scotia, became the world's first radio message to cross the Atlantic from North America. And then he sent another one from the UK to Massachusetts, which is a little bit further. But it is interesting that Glace Bay Cornwall. So December 12, 1901, a wireless signal was sent by Thomas Barron and Poldhu to St. John's in Newfoundland and received by Marconi. The technology was a precursor to radio, television, satellites, and the internet, with the Earth station at Goonhilly Downs a nearby example. This was the Canadian station that Marconi received from Cornwall. And I don't know how many miles that was across the ocean, but we can just do a quick. So Nova Scotia is here, or was that St. John's? St. John's. That one. Okay, this one, not that one. And so here to here, that's this is 200 miles, so 1, 2, 3, 4, 5, 6, 7, 8. So I don't know, maybe 2,000 miles plus the curvature of the Earth. Yeah, that's still quite a bit of distance. So that was more than 100 years ago. A telegraph could be transmitted, and apparently they were able to use Morse code at the time. Transatlantic or just maybe a generic signal. skepticism. Oh, 2,200 miles. Oh, they don't know the wavelength. 850 hertz. Three clicks. Morse code S. The clicks were reported to have been heard faintly and sporadically. There was no independent confirmation of the reported reception, and the transmissions were difficult to distinguish from atmospheric noise. A detailed technical review of Marconi's early transatlantic work appears in John Baldos's work of 1995. The Pole-2 transmitter was a two-stage circuit. And then he had to redo the test since there were a lot of skeptics. Coherent reception. At night. So then he also discovered that they traveled more at night. 700. Continuing to use inefficient spark transmitter technology, which could only be used for radio telegraph operations, long after it was apparent that the future of radio communication lay with continuous sine wave transmissions, which were more efficient and could be used for audio transmissions. Somewhat belatedly, the company did begin significant work with continuous wave equipment beginning in 1915. After the introduction of the oscillating vacuum tube. Okay, so the reason I wanted to mention that is because spark gap transmitters were outlawed in 1934. And not many people were using radio transmissions in the early 1900s, but of course those that were, soon realized that there was interference with other radio users, and they were using it was called damped waves, which was causing the interference. So it's kind of like this electric way. It's kind of like the Morse code is getting transmitted in pulses and through the air. There's a video on that actually that was made just 3 years ago. Electroboom makes a lot of really interesting videos. I didn't know he made one of these on SparkGap, but it could also, like, if you're stranded in the desert, like Death Valley or somewhere where you really can't really reach cell phone service, especially, you could actually use a spark. I mean, it's technically illegal, but it might actually save your life. So he talks about this spark gap. He makes a spark gap transmitter.
Get closer, and it goes dimmer as I move away. Of course, I didn't put an antenna on these, so I should do that. In AM radio frequencies where I'm at, it greatly helps if we ground the transmitter and receiver and have one of those massive antennas you have probably seen around the roads, at least at the transmitter. The radio waves, like a mirror, bounce off Earth and ionosphere, which is a charged layer in the atmosphere and can travel long distances. I have an extension cord I'll connect to my transmitter as the antenna and another extension cord as the receiver antenna. And I guess I'll just connect it to my ceiling light and a connect the other side to earth through my scope ground. Well, let's just move it all the way back in this corner, and I'll use the outlet earth to connect it to ground. There we go, no antenna connected. Don't see anything.
So, by the way, if you've never seen any of his videos, he's sort of like a professional stuntman. Like, he does a lot of dangerous things with electricity, and he gets shocked like in every video. So I would not actually recommend you try anything. He's actually like a professional, despite some of his you know, foolish looking experiments. But he's definitely one of like the funniest YouTubers that I've watched. And I also like all things electricity, so he's definitely one of the best gurus, I would call him. But anyways, going back to spark gap transmitters, a few months ago I watched the movie about about Eli Cohen, and it was on Netflix with Sacha Baron Cohen, and there was a scene, well, there were a few scenes where he uses a transmitter to communicate from Damascus, Syria to Israel, or some other number station, or number station is it's a station that receives shortwave radio cryptography, which is really just unencrypted Morse code. It might be encrypted, but it's they still actually are used. It's sort of like an open secret, depending on who you ask, but they are still used. And I'm not 100% sure that he was using a CW radio, but it appears that based on the interference that in the movie, there was this guy watching TV like nearby, and he was like kind of getting upset that his TV was getting this interference and he couldn't figure it out. But then obviously it's kind of dramatized, so it's like you can kind of visualize that there's interference. But no one else in the 60s, I mean, obviously there were telephones, but it's not like people had cell phones or other things that they would necessarily notice the interference. It's obviously more visible on a TV than a radio, since there's probably more background noise or more static on a radio. But one of the blogs said that I guess this was inaccurate, that he was using a CW, high frequency, unintended humor in the use of a transistor AM radio circuit board, tiny batteries and no antenna to send CW messages. Now, I don't know and then of course, the Soviet Syrian, I mean, you see that it's more like in a NCIS show today, but I don't really, I mean, this looks like a Morse code, this looks like a telegraph, but I don't actually know what they actually used. But I thought it would have been like a spark gap transmitter instead of a CW, but I could be wrong. In any case, it was an early form of wireless, like sending a text message in a way, because you could send it long distance. So I just did a brief calculation of how many miles it is from Israel here. So Damascus is here. Now, it could have been actually going somewhere else. Like, it might not have actually been going to, like, I don't know. It might not have been going to Golan or something. But it would have been able to transmit far enough to reach some other territory. It could have been maybe Lebanon or something. But it's interesting that they were able to use that. in 1964, that happened in 1965 or 64, something like that. And that was before cell phones and satellites. So not to say that there weren't other technologies like walkie-talkies and high frequency, but sending a text message, I call them text messages, but it's Morse code really. It has to be decoded by, pretty expensive and have heavy equipment. It's not something you can just use a portable device. But yeah, you can't use spark gap transmitters, but if you're someone like a spy, some of those laws don't really, you kind of technically get like immunity in a certain way. Not to say that you would want to try that if you are, but depends on what type of role or mission he was given. Definitely illegal, and that was in 1934. It was outlawed, so it's kind of, you kind of wonder like who would have detected it back then if they weren't looking for someone that they thought was a mole in the Syrian government. But anyways, I don't know. I'm not gonna speculate because I don't know if he was using a CW radio. I mean, they probably did have the ability to send it, and it probably would have been possibly easier to hide because it wasn't causing interference. But it's possible that he was using a spark gap transmitter. It's just such an old technology that like you wouldn't think. And sometimes people are like, oh, the movie's not accurate, but like, I don't know, maybe he was using a spark gap transmitter. But that's all I really had to say about that. And so next, coax, fiber optic. So there's definitely a ton of internet technology today. There's a ton of undersea cables. Undersea internet cables. So there's a map where you can see all the... So this is an early telegraph map in 1902, and there were a few that even went across the Pacific back then. And then a more modern, and then this is what a telegraph looked in 1925, or what was this, a phone line? I don't know. Transatlantic telephony was not developed until the 40s. So if that was 1925, that was not a phone. Submarine. And then in 2015, we have submarine cables, which are communication cables. But there's a lot more internet cables today. Internet, data communications. Transatlantic. Submarine cable. 23 terabits. And then I was also researching another. Oh, this is when they he was working on the telegraph there. And then I was doing some research on shortwave radio a few months ago, that if you're receiving a really faint signal, even if you're decoding it for Morse, you need really sensitive equipment, and you need to use a lot of power to do that. So it's not very efficient, but it is possible to send data over shortwave receivers. It could even take hours. Let's see here. I recall reading something. Marconi. This was about maybe 6 or 7 months ago. So there's some new technologies out there that have very low power data. They don't transfer a lot, but like for example, yesterday I saw that there was a new Raspberry Pi released, and I read the whole article, and I read that it uses 8 watts of power, and it peaks all the way up to 12 watts, and there's a new power cable adapter that you can buy that goes up to 25 watts, just so you can power the peripherals. And I recall reading mentioned I quoted it in the link, but I'm just looking for it here. This is not the fastest way to search for something. I should have searched the other direction, but okay, I'll just start it over here. Might have already missed it. So it's using a 16 nanometer processor, which should use less power, but because it's clocked at 2.4 gigahertz instead of 1.8, it's gonna use more power. But it is more than twice as fast as the Raspberry Pi 4. And so it goes on to say, okay, so it says here however, much higher performance ceiling means that for the most intensive workloads, and in particular for pathological power virus workloads, peak power consumption increases to around 12 watts versus 8 watts for the Raspberry Pi 4. So this is much more of an enterprise type of device. It's for more serious work. It's not really I mean, you can use it for education, and it's probably going to be a useful board because it has a lot of peripherals and things like PCI Express, which has finally been added like officially without having to use like a special adapter on the compute module. So I mean, it's definitely going to be a good board, but when you compare it to the original Raspberry Pi Model B and the Model A, it only used 1 watt. So it wasn't a very powerful thing, but I mean, it could play 1080p video. It could play, I think, H.264 or whichever codec it was using. So I mean, it was still capable of using Debian or Ubuntu Raspberry Pi OS for basic computing, and that was 11 years ago. The first one, it was Model B, and then they released the Model A. So the power consumption has always gone up over time. So if you look at the Raspberry Pi 4, 400% CPU load, which is like the viral workload, 6.4, but they probably meant 8 like as like a peak. But continuously, it's probably going to be running at 6.4 watts. And returning to this other one here, I think it was Hackaday. So the power consumption ideally could use about 5 to 10 milliwatts. And if you were to combine a microcontroller or a chip that runs at 2 to 10 milliwatts, you could solar power an entire cell phone, because there's other components that only uses. So if you were to check the amount here, there is Corva. So they just released this tiny little thing a couple of days ago, and these run at wireless data sheet. So the new one is 55011, and that appears to be cat. It can operate in both, but it says 1/2, so I'm not sure if it's referring to LTE Cat NB1 or LTE Cat NB2 or something else, but it looks like they both are supported. So the data rate could be 26 or 127 KB, which is a lot more than Morse code. and the power consumption of these, even if you're not using it, you could, in theory, limit the power consumption to it kind of waking up every 3 hours or like every 43 minutes. So it's not constantly pinging the cell phone tower. And that could be a very useful way to limit the power consumption on something like a solar-powered cell phone. Now, it's not to say that you want to limit the consumption to make it harder to use, but it can be a really useful way to conserve the power on a cell phone, because you never know how much data you're going to need. So if you just wanted to make, I mean, this is really early not chat GPT, but Stability AI. I just took some of these models from like a beta that I could get some, I think I only had like 200 generations that I could test, and they turned out really bad, but this was like, I don't know, 8 or 9 months ago, or no, maybe a year ago. And some of the stuff is not good at all. Like, I read that Midjourney is a little bit better for AI, but I don't really like doing anything AI very much, because a lot of it turns out really Frankenstein-y. So I think this is probably the only one that is somewhat close to what I kind of had in mind, because like you don't need a really large screen, you just need one where you can type. But this isn't really a QWERTY keyboard, it's not even a T9 keyboard, it's just what Stability AI thought it could guess what I was thinking. And it looks like a calculator, but in theory you could charge the solar panel, that you can charge the device by putting little solar panels on each key. But the format of this might not really be good, because typing on a T9 isn't really efficient in terms of typing. But if you use a touch screen, or whether it's resistive or capacitive, that isn't necessarily any better, because the accuracy and the quality of a screen really depends on how durable you want to make it. And you know, it's very possible that it won't really last very well. So but I do kind of like the concept here, because you know, you have a little bit of screen, and this screen would be most likely reflective, like those old calculators. And it could even be segmented if you want. I mean, you would probably save more power using a segmented display, but then it might limit the amount of resolution. So tying this a little bit back to what I was mentioning earlier, so Morse code in a way is just kind of an extension. IoT in a way, it uses a lot more data, but you can still transmit a lot of data. I mean, you can even browse a very basic web page on 26 kilobits per second. But if you're using this over the air, compared to something like a wired modem, a dial-up modem, it's not gonna always get 26 kilobits per second, and the latency is gonna be kind of slow, so it's not really gonna be real-time where you're going to get a response really quickly. I mean, if you're only sending a few bits per second, you know, you might get a response in a few seconds, but you know, this isn't very fast. Now, if you're getting 127, you probably can actually maintain, you know, a cell phone conversation using a very low bitrate codec. And also, I'm not really sure if this modem can actually be used for applications, or if it only works with certain microcontrollers. So that's another issue. These are more designed for like more user space and like human computer interfaces. So you're actually using more data because it's more visual than just like a sensor transmitting, the temperature every 10 minutes or so. So these are very low power. Like they limit how much power you can use, but they're very interesting in terms of their potential in being used for a solar powered cell phone, if you wanted to develop that. The other thing I remember seeing, and even the displays use very little power. Like apparently this only uses 5 microwatts per static image, and then 30 microwatts for 1 frame a second, and then 180 microwatts at 6.5 frames per second. So it's not even using a milliwatt technically. And that means that if you were to charge your device, you wouldn't even need a battery, because it could actually store all that in a capacitor. There's other components that might use a little bit more power, like the keyboard, because it's not really clear how many keys you need. If you wanted to develop it, you might save a little bit of power by just having a few keys and saving on like material costs, since you only need a few keys to go. If you're just using arrows and a few like cancel and OK buttons, you could probably get away with just like 5 or 6 buttons. But if you wanted to do an entire keyboard, that might use a little bit more power. Not technically, because I mean, if you're only typing on a few things at a time, it's not like you have to use more power necessarily, but you're still sending more signals, and it has to process that faster, so it could have to consume more power. I don't know. Keyboards are pretty complicated, but another developer, Andreas Eriksson, he mentioned a few keyboard he mentioned these TI keyboards, and I don't know how much they use, but apparently they're like really low. Well, this is near field, but there's another one that's a mechanical harvester, and then there's this one here, which is an ultra low power keypad interface that works with a microcontroller. So you may have to use another microcontroller to interface it with a chip of your choice. But in theory, you could just use one microcontroller or processor that interfaces with this keypad. It uses only 1 microamp while waiting for a key press, and consumes a maximum of only 2 microamps at 3 volts if all keys are pressed and held simultaneously, which is not even like a real world condition. But in theory, you could use this as like your QWERTY keyboard. I don't know how many keys this supports, but if you're using this as a keyboard, you could in theory 20 milliwatts. That's quite a bit of power because you're not only using power to press the keys, but you're also using it to transmit. So wireless isn't necessarily lower in power than a mechanical. And this one, I mean, this has been used too. I don't really know too much about it, and if it's really, cost effective to have like 30 or 40 keys for a keyboard like this, because that might not really be lower in cost than some other system. And there was another keypad, wireless, that this one here. It's kind of like the other one that I linked, but it does mention the power consumption, and I think it uses. So the data sheet will have something like 67 milliamps, which is quite a bit. So I'm not really sure if it uses a lot of power compared to the Corvo one, but they appear to be very similar in terms of their capabilities. I don't really know if this one uses more, but 6 volts. I mean, there's 24 pages, so there's quite a bit of information, and you can probably calculate how much power it uses when it's actually transmitting, but it's not something that's going to be transmitting continuously, so it probably wouldn't be using a ton of power. One advantage of an LTE band is you can use it with a lot of modern 4G, I think. I remember looking up the T-Mobile NB IoT. I remember reading that T-Mobile supports it, and I think AT&T also too, but apparently it covers almost everything. And the band is, I think, channel 4 or band 4. Low power, LTE for machines. But I mean, I don't see any reason why it can't be used as a cell phone. Like, if it's just designed for like microcontrollers, or there's something that's prohibiting it from being used as like an actual cell phone, I mean, I can see that, but I don't think there's an actual thing stopping it. But the range of these things compared to something like 600 megahertz, I think it even operates in that range already. So this is, and this was rolled out a few years ago. It's not really new, but it's the low band 5G. I think it's technically part of 4G, but it is. So it's not really clear if you need an extra, if you need to be using this cell phone tower, but there are some other IoT. remember reading it somewhere else. Or maybe it was that other article. Nope, not that one. I mean, there might have been something on that. But, so yeah, I read here that Cat-M is viewed as a second generation of LTE. So power consumption is lower. I mean, some of the power consumption is proportional to how much bandwidth it's using. So 1.4 is going to use less, and that's what makes it, you know, narrow band. So it's compatible with existing LTE, which might be good for a cell phone. And then there's this other one here, which is more like the Kecta one, the BC660 and the QM55011. And that one apparently does not use LTE. So it's using either 5G or 3G. I don't actually know. But apparently the gateway is something on the cell phone tower that it needs to communicate with another cell phone tower, or there's some other server on it that's technically part of their infrastructure already that they don't have to install. Or this gateway could be something on the phone or the modem that you're purchasing. So I don't really know it, but it says that it's using less equipment. So in the long run, it could be less expensive. But that also depends on how long 5G is deployed. I mean, if they phase out 5G in 10 years, that's not really going to be a useful thing. But I mean, for its time, it could be less expensive for the consumer and the wireless carrier. But and this is not even in every country. It could even be just the United States, or it could be like in some countries. So, for example, this is also like the other one, but it doesn't appear to be in many. It is in some countries, so it really depends on what you have. So that's this one over here. So this one, I don't think it's in the United States, but it's similar in terms of low power. So you know, it might be good for you, or it might not. But these three are definitely the most interesting, and these, of course, too. This one, Cat-M1, and then this one, I don't know if it uses more power. It looks like it does, but because it's release 14, it could mean that it just supports more, like this one. Cat 0 goes all the way from 1.4 to 20, so you know, it's hard to say which one is better. Not deployed. So that one, I guess it was never even used, so you can't really find it anywhere. But this one here, this one does actually look interesting, because it's not as slow as 180, but it's still low power. So that would probably be this one, I think. Cat-M. I remember reading that. Oh, this is the IoT one. NV2. And there's quite a few. But yeah, that's all I really had on that. I can't remember anything else. And then I also remember reading map of IPv6 internet. So I saw this a few days ago, yesterday actually, but it was released a few days ago. And so this is like a map of IPv6, but there's so many addresses. I mean, there's trillions potentially, so you can't really visualize it. But this same video maker made a really cool one a few years ago, a couple of years ago. And this is how computer networks kind of evolved over 20 years, more than 20 years. So when they started out, there were, a few there were only a handful of big internet providers. And as time went on, I mean, it'll label some of the providers when it zooms in. Okay, not yet. This might be the video without labels. But there's another video where you see like MCI communication and but there's obviously a lot more internet networks today than there were 20 years ago. So it's a lot harder to calculate the number of networks. But that was just one of the things I was thinking about. If solar powered networks were developed or deployed, because then you would have all these, you would have like billions, or not billions, but like millions of little islands that connect, and IPv6 could technically be used to connect each mini WAN to a larger WAN, which is really what the internet is, just a collection of WANs. But it could be more fine-tuned or more granular than before. It's not really clear how you could design a network that with that many nodes from node to node, kind of like peer-to-peer, like BitTorrent, because you can connect to any other node, but the addressing system still depends on like DNS and other gateways to other service providers. So there's a lot of bottlenecks in that. So it's not really possible to connect all the other devices directly unless they're sharing some sort of airspace that isn't conflicting, like if everybody has a certain bandwidth. But it's not really possible to do that over the internet, over the air, since it's probably faster to use a fiber optic cable. But again, that involves a number of links to little hubs of internet providers. So yeah, this whole video is just sort of tracking the progress of writing and as a technology, and then it gets converted into Morse code, which is an efficient way of transferring letters and characters over telegraph cables, and then in the 20th century it gets transmitted over the internet, which is binary code. But now it's like you can use wireless over satellite, and you can use it over wireless, like cell phone towers, but it doesn't really necessarily make it easier to connect if there's different, competing standards, and you can't always agree on the standards. The OSI model was an example of that, where it wasn't adopted because the TCP/IP was a lot simpler. But I remember reading about that when I got my certification on CompTIA, and I always found the OSI interesting, but just reading that it had like hundreds or thousands of pages for the specification, it's modeled after many different, like people assumed it was like this European standard because so many different countries have all these specifications, but it wasn't really necessarily European. It was just the perception that it kind of followed a bunch of very highly regulated standards. OSI has 7 layers, TCP has 4 layers, and that isn't necessarily better because sometimes there's more ambiguity in the layers which do multiple things. But just for the purpose of connecting different regions of the world, like TCP/IP will do, and it still has been useful for this many years. So I mean, it's not really going away. It just so happens to be a lot more practical for most needs. But yeah, I don't think that's really going to be an issue for developing a solar powered phone. I think the main issue in developing a solar powered phone is just getting a lot of these technologies to be worked on by companies that already have these. I mean, they could already be working on it, in secret. It's just that it seems like most of these technologies are already mature in terms of the power consumption, but the components themselves are very expensive and they are pretty hard to program. So even though this might use the absolute lowest amount of power, it doesn't mean that it's going to actually be the most practical. But in terms of having, a color screen, a large screen, and a low power one, like this is actually one of the best screens, and this one's a little less expensive.
Hey, this is me testing out a 2.7-inch diagonal sharp memory display.
It's like $50, I think.
Low energy, faster than e-ink, but very daylight readable displays from Sharp. This is the same display that's in the Playdate, the little cranking game that's coming out shortly. And I found the part on DigiKey, and I thought I'd make a little breakout, and our library worked with it perfectly. I just did a little bit of speed up, so you can see how small and readable the text is. Yeah,
like these screens are very clear. Like they have a nice sharp, despite the, no pun intended, but the screens are very clear in ways where the backlight doesn't really cause like this fuzzy appearance on the screen, because the LED kind of makes the screen a little bit blurrier in a way, because the light kind of interferes with the edges of the pixels that you're trying to look at. But there can be other ways to make it clear without having to rely on no backlight, but it gets a little more complicated. I know that OLEDs are really sharp. They don't have the same kind of what do they call it? They call it like backlight bleed, but it's like something that just causes the whole screen to kind of have this glow that isn't really needed. So a lot of smart TVs now have dimming zones. So you have like mini QLEDs quantum LEDs, quantum nano dots by LG, Samsung. And they have like a number of smaller zones. They might have like 50 or even 1,000, but it's nothing like an OLED, which has a single, light for each pixels or number of pixels. So it's there isn't a whole lot of innovation in just like the non-emissive displays, but in terms of solar power ability, like they're really the best types. Now this one here it's only a write-only screen, so it's not like one where you can really interactively use it as a display, because everything you draw on the board, it has to be programmed. So it doesn't have a driver where you can like use it as a terminal or a WordPad. But in theory, they could design something like this and then make it like an actual like screen, even if it's monochrome. I mean, it would still be a really good screen for coding or just reading. Because even like e-ink screens or e-paper, they have like these round like bubbles, so they're not really sharp in the same way. Like you're looking at like you're looking at a bunch of little magnetic oil electrophoretic bulbs that kind of rise to the surface, or they get repelled away from the surface. So they do form a picture, but it's not sharp like an LCD. And that's why they aren't really that popular, I think, because I mean they're fine for just reading like casually, but it doesn't really. It's almost like you're looking at a painting or something, because everything is like smooth on the edges. So it's almost designed to be like a softer touch. Like when you're doing photo editing, you can kind of blur things, but for reading, it's not really conducive to reading like efficiency. Now, efficiency is sort of subjective, because sometimes you don't really want to read, but sometimes if you're doing certain types of work, you have to be more like you feel more efficient at just reading when you have like square pixels instead of round pixels. So it's definitely a weird thing to suggest, like, hey, you should have e-ink in a solar powered laptop. So I'm not gonna say you shouldn't use it, but there's definitely there's other ways you could put e-paper without using round pixels, or that's what it looks like. So there is a way you could get e-ink to display different types of non-emissive, but I mean it's not the only one. I'm sure there's, and then they also have ones that display faster, but that can also lower the lifespan of it. And that's another one. And these also look really good. I mean, they have a slow refresh rate from Pimeroni.
Great visibility in sunlight and
Pimeroni sells it.
Even when unpowered. Commonly, applications have been signage, e-readers, or simple project dashboards. The technology refreshes slowly, so it's never been for fast updating user interfaces. More pixel-dense version.
Now these are also really interesting. I like these. I mean, they look good for image picture frames. And this is what I was talking about. The hexagons are not. They're off center. Like they don't actually fill in the blocks neatly, and that's what kind of makes it look a little off, a little rounded. it looks
When the
kind of
particles
like
are drawn to the top of the
blur,
eye
not
with
blurry,
bubbles,
but
you
just
can
kind
then
of
see their
like
color displayed
like
on the
leaking
e-ink
ink or
screen.
something.
On the table before me is everything you need to set up your Pimoroni e-ink display.
And,
Naturally, you're
and
gonna
it's
need a
not just due to those. It's
screen.
just
You're also gonna need a
it's all
Raspberry Pi
e-ink
setup to
in
run as a
general.
desktop computer. If you need help with that, we have a guide linked in the description. We are using a Raspberry Pi 4 Model B, but this can be used with all Raspberry Pi single board computers, like the Raspberry Pi Zero. You're also going to want a micro SD with the latest Raspberry Pi OS.
But they
and
use a lot
small
less power
screwdriver.
if you're only
If you
refreshing it
enter onto that
a few
terminal command, you're going to
times.
notice your screen.
So it's fine for reading. It's probably even fine for sending like just a text message or something. Because if you're only typing a few things, I mean, you can wait until the refresh can actually send a few keys in a batch in a way, because you're not really seeing each key. You're not seeing each key like getting refreshed, but by the time it refreshes a second time or a third time, you're probably going to see most of the keys that you have refreshed. And these are, they do take a few seconds to refresh, to kind of clean the screen of the refreshes, but...
And there you go. To get this functionality easy and all the time, you're going to want this Python script to run on boot. I demonstrate exactly how to do this with cron tab in the full write-up guide, and if you actually want this script, it's going to be there too. Here is my current application for this sweet display. I've set up...
Well, thank you for watching. I just wanted to cover some recent advances in wireless technology. I don't really know much about this brand. I've never really heard of it. I know there was another... I've heard of the other brand, the Kectel one, for a few months, but this one, 663 megahertz, could be like the low bandwidth, which apparently can cover several tens of miles. I don't know how many miles. Low band 663. I'm guessing it's 5G, but I remember reading... I haven't seen this one before. LTE, smart meters, asset tracking, wearables. So wearables could technically be like a user device, so there's really no reason it can't be used to develop like a Nokia flip phone or something. B65 2G, it can support 2G power handling. Oh, well, low power, expend battery life. But one of the things that can support is eDRX, and apparently that sleep mode can last as little as every 10 seconds instead of pinging every second. But this one here, I like this article better because I remember it covering low power saving mode is another technique, but these apparently use release 13 which was the one in that Wikipedia article, but it says in the past, with EDRX predecessor DRX, without the little e, the length of time that a device would sleep before waking up was dictated by the network, typically 1.28 or 2.56. With EDRX, the device, rather than the network, chooses the length of time it will sleep, a period referred to as the EDRX cycle. Since the device is not reachable when it is sleeping, the time to reach a device depends on how long the application developer sets the EDRX cycle. So when they say application developer, they could be referring to like an Android or iOS app. They could also be referring to the hardware developer. So it could be like the QM501 or the Kectel. But at the very least, if you're buying something and there's a set amount of time that it actually that it's designed to wake up, then at least you can choose that product rather than the network constantly, pinging it and not being able to choose how to limit the power consumption of a phone or a laptop with a 4G modem on it. And obviously you can just shut it off, but sometimes you kind of want to let it in sleep mode, where even if you're not using it, or you are using it, but you want to like be notified every like 10 minutes if you are getting an email without having to manually turn it on and off every 10 minutes. You could, in a way, use one of these modems to program it, or to just buy one that is only fixed at a certain ping. But typically you would think that one of these modems will let you toggle if you want to set it to 82 seconds or 3 hours. So not static. And this isn't a brand new technology. It looks like it's been around for quite a while. But what I know is that if you have like 30 or 40 apps on your phone, some of these apps are going to be pinging the cell phone tower more frequently. So it would be nice to kind of know, to make sure that all the devices are only using it at a certain time, so that you can, put a lock on all the devices that are using the wireless. So you can still put it in the background, but you're not getting a million updates at once. So you can at least limit the power consumption, or at least know how much power you're going to be using. And there are some trade-offs where it doesn't really make sense to put it in the sleep mode, because it might be using more power to wake up every so often. So in some ways, it may be better to use a different technique. But apparently in this case, it says it takes much longer to wake up out of sleep mode and is active for a much longer period of time, because it must connect to the network before receiving any application data. So one of the advantages of EDRX is it doesn't actually have to connect to the network to receive data. Apparently the EDRX needs to wake up and listen for 1 millisecond, whereas with PSM it has to wake up and transmit messages for 100 to 200 milliseconds. So I guess that's one of the main advantages of EDRX. The whole action of checking if there's any data only takes 1 millisecond. Whereas in PSM, the whole checking if there's any new messages takes 100 or 200 milliseconds every single time it checks. So that can add up, but it just seems like this is this technique hasn't really been exploited in a way that has been combined with other technologies. results in the absolute lowest power minimum. So just like this AMBIC processor, this microcontroller is designed to use the absolute minimum low power, at all times that it's running. So if it's running at a fixed speed, you can predict how much power it's going to use over 24 hours. It's only going to use like maybe 1 milliwatt hour or 5 milliwatt hours. And knowing that, you can design a battery that doesn't need to use, 30 milliamp hours. You can use a really tiny, 5 milliamp hour battery, because that could be enough for, several hours if you're only using, 1 milliamp hour. But typically, if you're using a 30 milliamp hour battery or capacitor, you would need to, design your whole system to use maybe 5 or 6 milliamps, so that it'll last 6 hours if it's using 5 milliamp hours. But again, a lot of these things are not optional in the sense, because if you're using a battery that's like 30 milliamp hours compared to a 3000 milliamp hour battery in a cell phone, typically, it's definitely going to be a lot smaller, and technically you don't need as little as 30 milliamp, but it's such an efficient level that you could save a lot of money on lithium, because you don't really need any lithium in a capacitor. But if you're going to be using it, like the trade-off isn't so much so you're just replacing the cost with less, with more expensive, solar equipment like the panel, the power manager. So even though you're paying more money on the solar power and the newer low power processor, it's more about having the ability to be solar powered than just trading, more battery space, more space on your phone for other components. So in a way, you're getting a lighter phone. You don't have to use a heavy battery. So that's one of the trade-offs, trade-ups, I guess, because if your phone is better to be light, I mean, sometimes it's good to have a brick as a paperweight, but typically having a lighter phone is going to have advantages in itself. But beyond that, the value of having the phone to be solar powered is going to be far greater in terms of durability, like lifespan, in terms of upgradability isn't necessarily going to be needed for certain types of tasks. I mean, you technically could upgrade it for more features, but it's still going to be useful, 10 or 20 years from now, if there's still a cell phone tower that's able to send those types of signals. I mean, if someone's phone number changes and you can make a long distance phone call, you don't really need to change it, unless your carrier isn't going to offer a certain data package, or a prepaid data package that only uses 500 megabytes a month. But obviously when you need more data, then you're going to have to buy a larger package. So your data plan is going to need either 2 SIM cards or an eSIM. But the concept that this is supposed to replace a regular cell phone is not really the point of this project. It's more about having a backup phone that is just for like very basic cell phone communication, like making a phone call and sending a text message, and like checking the forecast, or when the next train is coming. Like, there's so much utility in a basic phone that you don't actually need to invest all that extra hardware and licensing on something that's far more omnibus than something that's like a 30-year-old technology. Because if you ever used a flip phone in the 1990s, they were much smaller, for one, and they were actually a lot faster. Like, if you use a Nokia Symbian, that was the early 2000s, but they were so much faster and just doing very basic tasks. And they were also using real-time operating systems. So the phones today, they can take two paths. Like, they can go bigger and more hungry and power hungry, and they can throw all this new hardware on there. You can get satellite connectivity, you can get AR, you can get VR, you can get like everything you might ever want on like a really powerful desktop PC. But you don't really need that for a basic phone. Like, it might be convenient because it's smaller than a laptop, but for all that stuff, you may as well just use a laptop, because at least you can like use a full-size keyboard, and you can edit your work in a way that doesn't require a touchscreen. And how can you really trust AR to understand what you're doing, especially if you're writing like James Joyce? I mean, he had a million typos in Finnegan's Wake, and then he released like another edition, I think, with the typos corrected, because I think his editor wanted to correct them, but he was like, no, these were not typos, they were like plays on words. So the whole point of autocorrect, it's not something you really need. I mean, you don't have to use it. It's optional. It might be useful when you're trying to do something normally, but if you want to write like something interesting, there's really no reason for AI to be analyzing what appears to be gibberish. So I have Finnegan's Wake. I only read like maybe 30 or 40 pages, but it's not like a typical novel, like where it's just simple to read. It's more about if you're bored of reading and you want something to read. It's written in that sense. But there's plenty of information on a smartphone that makes it cost ineffective, because it's so expensive to make a new phone that you could almost open source the hardware if you design a very basic phone, and you can always upgrade it later. Like, if you make a display driver that can support more advanced resolutions, it doesn't mean you have to use this very low bandwidth, low resolution motherboard. It's just something to kind of get the platform started, kind of like Linux 1.0. Obviously that went on to grow in size. So this project is started out of an interest in developing a platform, and it's kind of like this idea that's trying to become more portable than the hardware before it, and that's how Linux got started. Linux was a way to get more portable away from machines that were using Unix. And Unix was licensed by Bell Labs, and Unix was designed as a reaction, or just a way to make it more portable than the Multics. And I just found that out like a few days ago. But there were machines in the 1960s that were larger than a washing machine. They were like three washing machines wide, or larger. And those were using the first monolithic kernel called Multics. And I think it was a time-sharing program. No, it wasn't time-sharing, but it influenced Unix. And the PDP-11, if you look at it, it's like a really tall machine, but it's still smaller than some of the Multic systems. And then look, in the 1980s, you have Minix, and then you have Linux. Well, 1991. But Linux could be installed on Intel. And where are we now? You have Linux that's bigger than you have Linux, and then you have it's larger than 3 megabytes. It's like hundreds of megabytes in size if you look at Debian. So I mean, it's not necessarily that big. I mean, you can make it a little smaller, but you're not going to be able to fit it on a solar-powered phone in this decade, unless you make it like 4 or 5 megabytes. And if you make it 16 nanometer like the Raspberry Pi, you could actually make it solar-powered if it's only like a 2 megabyte RAM kernel requirement. But that would be like Linux 2.0 or Linux 2.6, something like that, where it only needed like 4 megabytes of RAM. But that uses a lot of power, so if you can limit that amount of memory by making just like 1 or 2 applications, then you could develop a processor which is only using like like 2 to 4 megabytes of RAM. But I've written plenty of that, and I need to drink some water because my throat's getting dry. But thanks for watching, and my name's Giovanni. Hope you like this video. I will try to make a bunch of different videos related to this in some kind of way, but I kind of know exactly what I am looking for in this project, so it's kind of like its own thing. But it could be very universal in a way, like the ATX standard, at least for system building, because this patent was made in 1995, and they designed it to lower the cost of the board itself, but it wasn't necessarily like if you compare this to the Raspberry Pi today, I mean, there's a lot of differences in terms of the size. So because it's so large, the ATX standard doesn't have the same kind of constraints. So when you're working with a mobile standard, like even the mobile ITX was a carrier board, which is what SparkFun uses on some of their carrier boards. But this was something that never never took off, and it wouldn't really be really helpful today because you can get a Raspberry Pi for something like this because it's smaller, so you don't really want to use it. This is just something that at the time looked like it was going to be a good idea. So that's one of the main reasons why there isn't a standard right now, because there's so many different technologies that are getting integrated on boards and getting phased out. So it's kind of hard to make a fixed mobile standard, since there's so many technologies that that you might not have thought of, like a satellite antenna, or that. So when you have to design a board, there's only so many places you can put that without having to radically alter the orientation of the I/O ports, like USB, DisplayPort, DSI. Those are all things that would go into a tablet or a cell phone or a laptop. But I mean, it could be done. It's not. It's just you have to get a bunch of designers to agree on that. But there's no indication that anyone would want to agree on it, because there's benefits to having a walled garden. You have this exclusive thing, and people will deal with that because they have a certain feature and they don't care about it because they're not planning on using it for more than 5 years. But I mean, when you see all these single board computers, at the very least there could be a consortium of 5 or 6 that agree on a standard. So in a way, it's just kind of arbitrary. Like if you're just focusing on one technology and you want to integrate it in a board, I mean, there's a lot of people doing that. But if you're just looking at the big picture and you see a bunch of people doing that, you can see a pattern that's been around for a number of years, because in 2012 the Raspberry Pi was very innovative. It was better than this because it was smaller and it didn't even need a carrier board. So it did make an advancement, but at the same time it's not something that should be copied, because then it turns everything into a disposable. The standard shouldn't be disposable. I mean, it doesn't even have to be standard. It could just be harmonious. So, standard harmonization. So I read this phrase a few weeks ago. Apparently it's similar to standard, where it's more voluntary, but it also allows you to kind of have certain things that are adopted voluntarily, but it's just a slightly non-binding way of getting people to agree on something. Well, thank you again for watching, and till next time.